Okay, so let's change gears and do something different than license plates. So we're at a restaurant. We got an appetizer, entree, and dessert. So we've got this many choices for appetizer, this many choices for entree, and this many choices for dessert. I know you've seen this kind of problem before, so you just multiply them all together. So that's how many choices you have total. All right. How about you needing to choose one boy and one girl from a class that has 17 boys and 18 girls? Well, I have 17 choices for the boys, 18 choices for the girls. All right. 6 people are going to sit at a round table that seats 6. So how many ways can they sit? Well, the first one that I'm going to put down, he's got 6 places to choose from. Then the next one who's going to sit down has 5 places to choose from. And then the next one has 4. And the next one has 3. The next one has 2. And then the last one just has 1 place left. We saw a problem similar to this in our last section. So we've got 5 elements in the domain, and then I've got 6 elements in the codomain. 2, 3, 4, 5, 6. Okay, so how many functions are there? So functions, you remember functions, everything in the domain has to go to something. So I'm going, you know what? I needed to say one-to-one. How many one-to-one functions are there from a domain of 5 elements to 6? Okay, so this one element here has 6 choices, right? Then this next element can't go to this one, so he's got 5 choices. And the next one has 4 choices. And the next one has 3 choices. And this last one has 2 choices. And that does turn out to be 6 factorial. Okay, 5 friends going to a movie. They insist on sitting together. So I'm just going to call them A and B. So they could sit together like that, or they could sit together like that, right? And so they want to sit in a row. So I'm going to consider them as one entity, and then I'm going to fit the rest of the 3 friends in, right? Because 5 of them total, this already takes care of one of them. So there's 3 ways to set this guy down, right? And then because of there's how many other people, I've got 2 ways to set the rest of them, and then 1 way for that one. Or I've got 3 ways to place that one, and then 2 ways to place the other 2, and then 1. So that just turns out to be 12. All right, let's move on to these kind of problems. 4-digit integers from 1,000 to 9,999. Okay, how many are there? So you know how to count the number of them. That's going to be 9,999 minus 1,000 plus 1. So that gives me 9,000. Okay, so here we go with the more criteria. So I want there to be odd numbers. So that means you want to go to the hardest thing first. So that means this last digit has to be a 1, 3, 5, 7, or 9. So there's 5 choices for that last digit. Okay, so now I'm worrying about picking the other digits. The next digit you want to pick is the first, because this cannot be 0. So I have 9 choices here. Then I have, I want, because I've chosen one of the numbers here, and this does not say distinct. Okay, so I made sure there was not a 0 here. I made sure it was odd, and so I can repeat. So I can have 10 here and 10 here. So that would be the number of odd 4-digit integers. Okay, so now let's make them distinct. And then here in the next one, I'll make it odd and distinct. So if I do distinct, so the one criteria I have, this is the first digit cannot be 0. So there's 9 choices. And then the other digits, distinct, so whatever I chose here, I can't use here. So there's 9, and then there's 8, and then there's 7. So those are all multiplied. Okay, so now we're going to go odd and distinct. So the odd, again, there's 5 choices here, because that's the 1, 3, 5, 7, 9. And then This cannot be 0 and not the last digit. So if it's not 0 or not the last digit, that means there's 8 choices. And I've used 1, 2 digits already, so there's 8 choices for here, and then there's 7 choices here. Then I'm asking you for the probability that it's a 4-digit integer with distinct digits, not odd, just with distinct digits. So that's this one. So that's 9 times 9 times 8 times 7 divided by the number of numbers between 1,000 and 9,999, and that's 9,000. Oops, little typo here. So the next one, that's supposed to say item, like number. How many positive 4 even digit integers are there with distinct digits? Okay, always go pick the last digit because that's the hardest thing. So that's going to be a 2, 4, or 0, 2, 4, 6, or 8, right? So there's 5 of those. And then I want to pick this, so it's going to be not 0 and not the last digit. So there's going to be 8 choices there. And then for the rest, I'm going to have chosen 2, so there's 8 choices here and 7 choices here.